good morning, afternoon, or evening to all of you, depending upon your time zone. It's good to see you, like people joining us from all parts of the world. So that makes this session really global, right? So thank you all for finding out the time and visiting today's webinar. This is the third webinar from e-Zest webinar series, and there are many more to come. So I'm going to moderate today's session. So I will start with my introduction. So my name is Shailesh. I'm heading Digital Product Engineering Services Business Unit at e-Zest. I'm working or associated with e-Zest more than 18 plus years. So I help many product companies to build and transform software products globally, some of which were recognized by the analysts and investors. So total, I'm working in this industry more than 20 plus years. And I work with wide range of software product companies. Our company basically is a leading provider of digital transformation services for ISVs and enterprise. And we have been doing this since last 20 plus years. I hope everyone can see and hear us well. Yeah, so the recent pandemic has taught us one important lesson, that is testing. The only one strategy that is working well across all the countries is test, test, and test. It is the way to know the spreader and put positive tested people in quarantine. So like what we are doing is we are catching a bug. So don't get me wrong. So I'm not saying people as a bug. But what I'm highlighting here is testing approach will help to improve the health of the society. So if you consider software development, software is far different from this. Thorough testing helps us to ensure that we are not shipping the software that wired some system behavior to our customers. So our today's webinar is on the same topic. So we'll discuss today test-driven development for successful product development. So in this session, we'll learn how to successfully embrace TDD for high-quality software product development. So this session, I'm hosting with Cesar. So I'll just quickly introduce the session. So Cesar is a technology architect working with e-Zest almost like more than 5 plus years now. Yeah, so we have a good culture and people stay with us relatively longer than any other organization of our size. So Cesar is having, I think, 10 plus years of experience and like his hands-on experience in designing and developing SaaS-based products and platforms, mainly for healthcare and agriculture domain. Our client love him for his work and his friends and family loves for his cooking skills. So he loves cooking. He always posts photographs of his cooking on social media. Okay. So I will now start with a little bit about e-Zest and what we do and Digital Product Engineering Services Business Unit. Quickly, I will brief about that and then we'll start. We'll hand over the session to Cesar. So e-Zest, as I said, like we are 20 plus years in the business. So we are specialized and focus business unit at e-Zest for product lifecycle services. We have developed till date 100 plus products, out of which 5 plus products are featured in Gartner's Magic Quadrant, and 5 plus product got multi-million acquisitions. So I will little bit talk about our exact services, what we offer in digital product engineering services. So we start with the new product development. So wherein we convert idea into minimum viable product. Also, we provide product modernization service wherein we enhance user experience of the legacy application and a lot of technology migration work we do. Then also we provide services like managed services where we provide 24/7 support and like migration, cloud migration services. Also, we provide level 1, level 2, and level 3 support in this. Also, we provide integration and interoperability service, wherein we helping product companies to develop components to integrate multiple systems. So here we are using like high disruptive technologies like AI, ML, RPA, data, and IoT, those kind of technologies. Okay. Then last one, like digital revenue enablement. So where we help product companies to be relevant in this digital economy by like providing digital payment, gateway integrations, e-commerce, so that kind of services. So this is all about like e-Zest offerings. Like now I will hand over reins to Shehzad. So before that, just one last point is like if you have any questions during the webinar, then kindly put that in the Q&A or chat window. Okay, we'll pick up some interesting questions at the end of the session. Okay, and in just case, like if we run out of the time, then we are always connected on digital platforms such as LinkedIn and Twitter. So we'll try to answer your questions there as well. So now handing over the session to Shehzad. Over to you, Shehzad. Thanks.
Thank you, Sailesh. Thanks for the amazing introduction and setting up the mood. So without further ado, let's just dig in and get started for what you people are here. So today, you all know that we are gathered here to have an introduction to TDD and to get into groove and see how you can leverage TDD to build software products and what's the relevance, why should we do it, or why should we care about it at all. So as Shailesh rightly said that today's world is right about testing, testing, and testing. So what is TDD? So basically the first thing is TDD is an abbreviation. So the first thing we want to know is what's the full form, what it does it stand for. It stands for test-driven development. The full form is in itself self-explanatory what it is. So it's a development that we do, but it's driven by testing. So I mean, in the real world, what we do usually is we build software products, but at the end, what's most important is does it behave the right way? Does the product work it is intended to? And does it generate value to your customers? Did the customers get what they wanted to exactly? So in a way, if you see, it's more about the product behaving right and all the test cases getting passed successfully and all the test cases getting validated and verified successfully and working properly. So why not reverse the cycle, and instead of thinking about testing afterwards, why not think about testing before we actually start the development? Because the end goal of doing any part of development is to meet certain test criteria and the product to behave in a proper manner that it is intended to. So it's test-driven development wherein we focus more on testing. Then it's usually a practice. It's not a technology. So a lot of people think that it's a package or a framework or a tool provided by some company, but it's not like that. It's basically a practice wherein you think about testing before you think about development. Testing takes a lot of precedence because you have to build the product right. That's the main motto. So you test first, you design your test cases first, you think about your product in terms of test cases and acceptance test criteria rather than lines of code. So what you usually do is you design your test cases first, so which means that before you actually start development, you go on and you go on your whiteboard, you design your architecture and you think about stuff. And before you start your development, you think about how this is going to behave and how it should work. And then you design your test cases. And based on those test cases, you go on and you do your development, you go on and do your coding, so that the test case runs and everything works as you intended to. So it is acceptance test driven, which means that for a product to be successful, it has to be accepted. It has to be accepted by your customers. It has to be accepted by the end users, and it has to be accepted by everyone who uses it. So acceptance is very important. So what you do is you write your development, you write your code around those test cases so that the end product gets accepted. Then basically the requirements are translated into test cases. So you get some requirements that, okay, the product should behave in this way, the software should behave in this way. Then you translate them into test cases. Then based on those test cases, you do your development so that at the end, you end up with what actually you intended for. Then this is a concept of extreme programming, whereas testing is taking precedence and you test first and then you do your development. Now, as said, there are a lot of fears, there are a lot of concerns and a lot of reluctance. So test-driven development has been around a while, but that option is, I mean, near to perfect and near to 100%. There's very little adoption right now, and even if people think they do test-driven development, but actually they don't. So a lot of people think that it's unnecessary. I mean, why do we need to write test cases? Because we do have a QA. We are going to do manual testing. The customer is going to do acceptance testing. People are going to use it and they're reporting bugs, but this is unnecessary. They think that. Then they think that it's an extra cost because you are writing your test cases and the developer has to write test cases first. So it adds to a cost because it adds to the timeline. And it's basically one more step that you do. There's a change in mindset and everything. So there's an extra cost. Then they think that it's a loss of productivity because you spend some time writing and you don't spend a lot of time doing coding beforehand while you start. So you have to think about architecture, you have to think about test cases. You don't. So a lot of people think that it hampers the productivity of the developers because they have to devote their time in other activities rather than development. Then there's a considerable skill gap. A lot of people don't have the correct skill sets to, I mean, actually implement TDD, test-driven development in their code or in their daily life cycle. So that's one thing. That's one reason of reluctance, not picking up and not doing this practice. There's a problem with planning and schedule because I mean, even in agile ways, what you do is you plan your development and testing and deployment in parallel. But what you don't plan is you don't plan a developer writing a test cases first and then doing the development based on that. So it actually creates some problem with planning, and you have to manage schedules. You have to do everything according to that. Then yeah, one of the most important thing is deep-rooted mindset and culture. So this is, I think, in my all years of experience, whenever I have tried to impart training or talk to people about implementing TTT, this is the most important thing that has come out. People are just stuck at a place and they don't want to change. They have a particular culture, particular set of culture, and they have a mindset that okay, this is the way we are doing development. Why should we change it? Because it's working for us. Um, so this is the people have a mindset and people have a different culture which is difficult to change because TDD is all about practice, changing your mindset and everything, and a big change in attitude is required for implementing TDD. So these are the basic fears, basic concerns that people have, and the reason why people are reluctant to pick up TDD. Then I'm sure many of you might also have encountered similar issues, or you might already be in the similar state wherein you don't want to implement TDD, or you might have tried to, but you might have been stopped by somebody higher up in the order.
So, Sachin, I have one question here.
Yeah, sure, Shailesh.
So, because a lot of developers also join this session. So,
Yeah.
from their perspective, like how do you feel? How much it is easy or complex to learn TDD?
From my experience and my team's experience, and for everybody I've helped implement TDD, I've seen that most of it is superficial. I mean, it's not actually very difficult. It's a very simple thing. So it's just one function calling other function from a developer's point of view. So it's nothing fancy about that. It's just that the concept is difficult to grasp because there's not much guidance about it. People don't think about implementing it. They don't think about adopting the practice. So there's a lot of mess. There are a lot of misconceptions, but it's really, really easy to grasp, and it's really, really easy to implement. And there are lots and lots of resources available right now on the internet, on lots of technologies available, and people have a lots of online tutorials too. So for now, at this point of time, it's fairly easy, and I think everybody should definitely do it.
So, from your perspective, it is a complete mindset change the way we do a software development previously and with the TDD.
Yeah, it's not a completely mindset change. It's just that we have to shuffle a little bit. So developers didn't used to think about how the testing is going to take place, what are the scenarios we are going to encounter. So what we are doing is we are taking the QA step ahead, and we are now asking developers to think about how the product will behave and what is the right way. So there's just a little bit of shift in attitude. I won't say it's a complete change. It's not very difficult to implement. It's not very difficult to adapt to. It's very easy. You just have to do a little bit of practice, and you have to do a conditioning of your culture. That's it.
Okay, thanks. Continue. Yeah.
Yeah. Yeah. So speaking of reluctance and concerns, obviously some of the concerns are well placed. They are genuine. So we will see them one by one. So one of the limitations and problems that TDD has is it requires an early design finalization, because you have to design your test cases, and you cannot design your test cases until unless you know your design of the architecture of the application. Because for an architecture to be testable and for you to write easily test cases easily and do testing easily, the design has to be appropriate, and you should know how to call a function or how to call a functionality or how to test something. Then building tests early. So building tests early, as just as we discussed, like just a shift of mindset. We have to build the test cases early, so the QA has to get involved early. Then the developers has to start thinking about testing first rather than just going on and writing code. So that's one problem, a change in attitude or change in process, whatever you say. Then it is difficult to determine business value. So sometimes people don't know how to determine how much value test driven development is actually creating for them. So that becomes difficult because there's no visible value for them, because they don't know how to measure it. So that's very difficult sometimes because people don't know about it. It's not that it's actually difficult. So that's why there's some limitations and problems around that. Then management of test cases. How are you going to manage test cases? Who's going to write them? Who will be the owner? Then if it changes over time, how do we change them? When do we run the test cases? And a lot of things about that, parity and everything. Then yeah, definitely gaps in skill set. So the current market scenario is that a lot of people are not adapt to whatever skill sets are required. So they are not, I mean, well placed to start TDD, learn TDD, and implement in their projects in real life. There are a lot of different technologies to choose from. That's one more important thing, because you have a lot of options. So you tend to get overwhelmed that what to do and where to do. So you don't have a clear path and you don't have a clear mindset that okay, this is the part I'm going to choose. So that creates confusion a lot of times. Now we have talked about concerns, we have talked about reluctance, and we have talked about why there are some issues that it's difficult to adopt TDD. Now we are going to talk about why we should do this, right? I mean, okay, we have to adopt to TDD and we should, but why? That's the most important thing. What value does it add? So TDD has so many limitations and bottlenecks, but why to do this? So let's just go and check ahead. So there's an old story. I mean, I think everybody must be aware of the old story, that thirsty crow, right? So there's an old crow. She or he, the crow is very thirsty, and there's a jar which is filled of water, but the level of the water is too low for it to drink from it comfortably. So it thinks about, the crow thinks, and comes up with a solution that it start putting pebbles in the jar, and the water level rises and it easily drinks it. That's good. I mean, yeah, it's very intellectual. It's very intelligent of the crow to do that and think about that. And it actually solved a pretty great problem for it. But that was too old, right? So that was very manual work and everything. And now, for the current technology and for current market trends, what you see is you see a modern crow. So this is the modern crow. So it knows that whatever tools or skill sets it used, that was of the past. You have something better now, which could actually achieve the goal faster and easier. So why not use a straw? It's easier, right? So what this basically signifies is you should not be stuck in a particular mindset. You should not be stuck in the past. Always try to modernize things. Always try to learn new things, because there's definitely always something new that will help you out. So you have a straw, you have TDD right now, and not only TDD, you have a lots and lots of advancements in technology, lots of tools, and everything is readily available for us right now, which we can use. So make use of it. Always stay current, always keep learning. That will be easier for you. And stay automated. So do as much as automation as possible. Now, if we are going to use TDD, it must offer a lot of benefits. That's why we are using TDD. So let's see what benefit it has to offer. So yeah, From my perspective and from everybody who does from the industry experts, so it has been noted that it reduces bugs, right? So you fix the bugs earlier. How you do that? Because you're doing the testing earlier. So now the developers are also doing the testing. They're thinking about the test cases. So a lot of bugs are uh, identified much earlier in the software development lifecycle. Instead of a bug going to the QA and then QA raising a bug and then a developer doing a rework on that and then again QA testing it, why not get them earlier? Why not detect them earlier? And if there's a bug, just fix them in the development lifecycle itself before going to QA. So it reduces the bugs by fixing them earlier. Find problem and issues early. So a lot of times there are issues with the design or issues with requirement. So instead of QA finding out or after the deployment, the customer finding out, okay, this is not how it is supposed to be. Let the developer find it out. Let the developer also do some thinking about the scenarios and test cases and everything and find problems and issues early. Refactoring and change is easier. This is, I think, by far one of the most important benefits of having TDD and automated tests in place. Refactoring is just a breeze. It's so smooth. I can't even tell you. Uh, Manual testing or manual refactoring is very difficult and it's very brittle. You can break the entire application in one snap. But if you have automated tests, if you have test cases that cover each and every part of your application, running them is just a matter of seconds. Whether if you want to, if you do a change, you don't have to worry about whether you are breaking other parts of the application because there are automated tests that will actually test that for you. You don't have to go on and execute each and every test case. You don't have to go on and execute the regression suite. The QA does not have to spend 5 days to test the entire application, right? Whenever you are do some refactoring or a change, you can do it in seconds. So just imagine how much time it would save, how much effort and money it would save. Then yeah, it shortens time loop in design changes. As we discussed, there are a lot of times we need some design changes in the application. The application is not built it is supposed to. So it shortens that time loop for changing. So I mean, this is the one of the most important aspect why we actually adopted agile. Like we have sprints and very short cycles. That whatever changes are there, we can identify them early and we can change that. So this TDD also, TDD automated test cases, they also help us do the same thing. Then it reduces the complexity of component integration. So your system has a lot of different components and they talk to each other. A lot of times you have different systems that talk to each other, like a insurance application. So an insurance applications might need to do address verification, and it might need to do claim settlement and transfer to bank accounts. So there are different external systems it must talk to, and it has to be integrated with them. Now, testing actually simplifies that and it takes care of that. So you uh, think about how your integration is going to take place and you design your application based on that. Okay. Then documentation. So test case is a very good way of documenting your acceptance and whatever scenarios you have. So when you write test cases, so each test case is like a scenario. So once you have the whole test case ready, the entire suite of like hundreds and thousands of test cases ready, so you actually have a documentation that, okay, this is how the product is going to behave. These are the scenarios that we need to take care of. Then predictable development process, you can easily predict how it's going to behave, right? So if the test cases pass, all the test cases pass, so you know that, you know for sure that your application is behaving as it is expected. Then intentional development, building the right product. Okay, so whatever you do, you know that this is the way I want it to be done. Then maintainability of code is a very big factor. So if the code is easily maintainable, because you can do refactoring very easily, the code becomes very maintainable. So you can do changes and everything. So a lot of time, I've seen developers leave the code as is because the cost of refactoring is very high. So you have to do refactoring, you have to do maintenance, but then you'll also have to test the entire application once again. Then there are risks that you will break the application. So it solves that problem. The test coverage of code is guaranteed. So it guarantees that you can easily cover the entire code in your test cases, so that it guarantees that all of the tests, all of the code that you have written is actually tested and it's well tested. Then eliminated repeating code. Yeah, that's the one thing. So I mean, you don't have to, you can easily do refactoring. So you can easily use the dry principle and continuous integration. main factors of CI/CD pipeline. Now, there are also some benefits that has value and for values and cultures. So it develops professionalism and discipline. So as we talked about a little bit, that it's more about a practice. So it develops a professionalism, it develops a discipline in people, that you have to adhere to some practices, you have to follow best practices, you have to follow design principles. Then it sets a common development process followed by the entire team. So entire team has to write test cases and the entire team has to follow something. Then clean code and performant code. So as you can do refactoring and all those kind of things easily, and as the tests are automated and you can run it in seconds, you can very easily do performance testing on that, and you can see how much time the code is taking, and you can refactor and make the code more performant. Then proactiveness in place of reactiveness. So instead of things going wrong and then you finding out what was the issue, you can actually design your test cases ahead and you can be proactive. Then better acceptance of the final solution. So this is one important thing, that a lot of times it happens that during acceptance testing, when the customer is testing it out, or when the large public is testing it out, what happens is they don't find the product to be a right fit, or the way it should behave, right? So because what we're doing in TDD is you're designing the test cases early, and you're thinking about how a product should behave very early in the life cycle. The final product tends to be much closer to what was actually anticipated. So it leads to a better acceptance of the product by the customers as well as by the larger audience. Now,
so Cesar, one
yeah,
question, really quick. So
yeah, sure, Shailesh.
CTO or product owner's perspective, product manager's perspective. So what type of quality matrices we should use to measure the effectiveness of TDD, and which you are using in your project?
Yeah. So first and foremost is whatever people are already using, they can use that. Then there are a lot of other things, like you can measure defect density. So before implementing TDD and after implementation of TDD, has the bugs actually reduced, the bugs that goes to QA or goes to production? Then they can measure the lead time. They can they can track the changes, track the change requests of CRs. Are more CRs coming, or the number of CRs has reduced? So there are a lot of things. They can also test out the code coverage and the quality of the code that's happening, the performance testing, and all those kind of things. So you can also tailor your existing matrices that you use, and you can also use other matrices like we discussed, like its defect density is there, then code coverage is there, then lead time of the software, how much time it's taking, and then how many
Okay.
bugs it's producing. So these are kind of
Okay.
you can use.
Yeah. Thanks. Yeah. Continue.
Thanks. So that is all about the theoretical part. Now I think it's enough about the theory. Let's dig in about the implementation. So how actually we want to do it. We want to do it, but how? That's the more important part. So there's basically a cycle. So this is a very basic cycle. What happens in TDD is, so we also call it as red-green refactor. So why do we call it as red-green refactor is? Because when you start writing a test case, your functionality is not implemented yet. So once you write the test cases, all the test cases will fail, right? So the first step is you write the test cases or rewrite the test cases, and you execute the test cases before actually implementing your solution. So the test case should fail, and it should fail with the expected status that okay, the functionality is not yet implemented. Then what you do is the second step, you check the test case, everything is working. Then the third step is to write code to pass the test cases. Okay, if your test cases fail, it means that your implementation is not up to the mark, you're missing something. So you go to the list of test cases that are failing, and you see that okay, these two particular scenarios are failing, which means there's some issue in these particular scenarios. You go to your implementation again, then you rerun your test cases, you redo your implementation, and until unless every test case passes, you do this iteration. Now, once the test cases succeed, that's the step number 4 here that you can see. What you can do is you can also do refactoring, because now the test cases are automated and the whole functionality is automated. So you can run your test cases within a second. So after the solution works, now you think about refactoring. If how you arrange your solution, you can do renaming of the variables, you can split out into different components, and all those kind of refactoring and everything. So then you go and refactoring, and then you run your test cases again, and do these things. So this is basically a cycle that keeps on happening. So you design your test cases, you write code, and then you do refactoring. If it fails, then you again pass the test cases. So this is the basic cycle that you see. So that's why it's called red green refactor. So at the start, when you start, everything is red because nothing is passing, all the test cases are failing. Then you pass all your test cases, the system is in the green state, everything is working. Then after everything is working, you can think about refactoring. So hence, red green refactor process. So this is the basic process that we do. Now, there are a lot of tools and technologies available. So most of the time, it depends on what tools and technologies that you are using already to do your development. So, I mean, a client-side JavaScript or server-side, I mean, C Sharp or Java, they use different frameworks. Now, there are unit test frameworks that help you actually write your test cases and that help you run your test cases. So some of the unit test frameworks are XUnit, JUnit, MS Test. The MS Test is Microsoft based. JUnit is Java for Java. Then for client side, for testing your JavaScript in the browser implementation, you have Mocha and Jasmine. So they help write your test cases. They are basically frameworks, and you can design your test cases based on that. Now, mocking frameworks are a little advanced, so we won't be covering these in details, but it's basically for isolating dependencies. So like we talked about, one system can talk to multiple systems, but in reality, when testing, you are not actually going to call that particular external system. So you want to just mock it, right? Okay, so if I send this particular data to that particular external systems, this is going to return me something. So just breaking the dependency, something like that. Then DI frameworks, so dependency injection frameworks. So they have a lot of, they have a huge role in actually implementing TDD and doing automated testing. So Castle and Inject, Unity, these are some of the available ones. Then test runners. So there are two things you need to understand. So writing your test case is one thing. Then running your test case is another thing. So unit test frameworks, they provide you a way of writing your test cases in which you can design, you can describe your test cases. But you need a separate set of tools to actually run your test cases and see which of test cases are failing, which test cases are passing, which has not been run yet, and gather all these kind of matrices and explore the test cases and errors and everything. How much time it took to run your test cases. So all those things, these are tracked by the test runners. So there are a lot of test runners. So Visual Studio IDE provided by Microsoft. It has an inbuilt Visual Studio test runner. Then ReSharper is a tool provided by JetBrains, so you can use that. That also has a test runner. Then Karma is for running client-side test cases like JavaScript test cases. So it spins up a virtual browser and runs all your JavaScript test cases. Then editors, you can use anything. So you can use Visual Studio if you're using MS Test and everything. You can use Eclipse, or you can use any text editor. So it doesn't really matter. You can use any editor, just like for programming, you can use the Visual Studio Code. You can also use. Now, what is an anatomy of a test? So test cases need to have some structure, right? So now we'll see how it is. So there are some concepts to know that there is a test class. So test class basically consists of a lot of test cases. So like what you're doing is you're testing an order service. So order service will have a lot of scenarios. So what you do is we basically create an order service class that has a test for order service. So like it can have 50, 100 test cases. It's just a grouping. Then you have a test case. So each test case is basically one scenario that you're going to cover. Then setup and tear down. So setup and tear down is something like for each and every test case, you have to set something up. For example, if you have to place some dummy data in a database or something, so that's a setup for every test case that you have to do. And after the test case has done, so what you need to do is you need to delete all the data and start afresh. So that's setup and tear down. So you set something up and you destroy something for every test case. Then test name is one thing. So you have to name your test cases appropriately. Test category. So you can define your categories. Like if you want certain test cases to run daily, so you can give them a daily category. You want certain test cases to run weekly, you can give them a weekly category. So you can base group based on categories. Also, category can be modules like order module. So order is one category. Then billing is one category. So if you want to run only one category, like you want to only run order category test cases, so you can do that. So you can categorize whatever you want, however you want. An expected exception. So a lot of times your code throws exceptions. So you should expect that. So sometimes you also need to ignore your test cases. So like suppose have a piece of code, but that piece of code is obsolete, but you don't want to delete the test case. You want it for future purposes or reference purposes. So you can ignore the test cases. So those test cases will not actually be run, and they will not be included in your test results. Then assertion. So assertion is basically saying or verifying that, okay, this is my expectation. Is my test case or is my functionality behaving in the same way or not? So it's basically like saying one equal to one, or if I'm placing an order, then assertion. So assert whether my order is placed. Just verifying whether your test case works or not, which means that verifying whether your functionality works or not. Then some test settings. So sometimes you also need to provide some settings to the test, like database connection, cloud environment variables, some timing durations, and all other things like connection strings and everything. So this is basically how a test case looks like. I've tried to keep it as much technology agnostic as possible, because different technologies have different frameworks, or test runners or test frameworks have different way of writing test cases. But this is a very generic representation, that there's basically a class at the top level, which holds all the test cases. Then we have set up and tear down things. We can set up something and we can tear down some things. Then we have test cases, like test is a test case here, and test cases can have multiple sections like arrangement, tax and assert, something like that. So test class and category that we already discussed, class versus test setup. So setup and tear down, they can be on a class, and they can be on a what do you say, a test case, a single test case. Then this is a single test case that we're talking about. So this talks about a game that opponent get hit in an encounter and on attack. So this is what's happening. This is the scenario that we're testing. So the name should be the scenario that you're testing. And then the test case has to be divided into three different parts. Of course, this is just a guideline of how to arrange your test cases. You are open to do anything. So there are lots and lots of other guidelines. So this is a specific pattern called a AAA pattern, what you say as an arrange, act, and assert. So the arrange section is basically where you prepare all the data. So here we are preparing all the data, all the objects, and we are setting the test case. Act is when you actually execute your function, when you actually execute your functionality. So where you are doing attack, right? So that is the actually act step. Then the assertion. So what result we are actually expecting? So we try to test opponent dot hits count should be equal to 2. So opponent should have been hit exactly 2 times. That is our expectation with this functionality. So that's we are testing. So this is the 3-part strategy for arranging a test case. Now enough about theory and concepts and everything. Now I think it's time for a demo. So we'll just go on, we'll fire up our Visual Studio, and we'll try to write some test cases and see how TDD can be implemented and how it helps, so that you have a very good idea about, so when you go home and when you can easily do it yourself. Now, what we are going to cover in our demo, so we'll cover basic structure of test cases and some projects. So how we create a test project and everything. Then we'll take a business use case, a very sample business use case, because we are limited for time. So we'll take a very small and simple business use case. Then we'll do its implementation using TDD. So we'll see how we can write test cases first and then actually execute our implementation. Then we'll compare it with manual approach. We'll try to see that if we had to do this manually, so what would be our position, okay? And then we'll come back and see some things. So yeah, I'll just stop.
Yeah, so Cesar, before starting the development, so one interesting question, just tell us like when not TDD, like in which scenario we should not recommend to use the TDD.
Okay, so there are a lot of scenarios wherein TDD is not recommended. So first and foremost important thing is TDD you should only do for your own code. So you shouldn't do TDD for a code that you don't own. You should not try to. Then there are a lot of legacy applications. There are a lot of legacy code that you run into. So you should not try to implement TDD for that. You can try to transfer it. Then there are a lot of POC stuff which is not actually not actually very important. There is some code that you write for your own purposes. Then of course, sometimes you have budget constraints. Sometimes you have time to market constraints. So you have to build out an MVP and you have to build a product which has you have to roll out in the market in a very short time. So as TDD adds a little bit of time forefront upfront, because you have to write the test cases and then you have to do development. So it increases the time to market in the initial run. So in the
Okay.
long run, it definitely helps, but in the initial run, it introduces some lag. So these are basically scenarios where you
Okay.
should not TDD. You can, but yeah, it's basically a time crunch kind of thing.
Yeah, yeah. Thanks for the
Yeah.
answer.
Awesome.
Yeah, I think we can
So
start with the demo. Yeah.
yeah. So I'll do a new sharing. Okay. So yeah, this is a basic editor. A lot of people might already be familiar with Visual Studio. They might be using it. Those of you who are not using it, it's just a simple editor. So don't be too overwhelmed by the technology or something like that. It's very easy. So just go on and just try to grasp the basics. Okay. So what I have here is I have a project, a sample project ready, because we don't have that much of time. We have a limited time, and I wanted to show you as much as possible. So I have a setup with you ready. So I have a package out there. It's a NuGet package. So this is something that I built for that. So basically, what it has, it's an error handling framework. So a lot of times, we are writing an APIs and everything in .NET Core specifically. So you have a lot of errors that takes place, and you don't have one specific way of handling those errors. So what this does is this introduces a middleware. So you have something to use ready-made, which you can plug in into your architecture, and it will do all the error handling and all the exception handling for you, and it will return your response in a particular manner and in a consistent manner. So we have some project set up. So this is basically my whole code. That's the core of it. Okay. So this is the basically the middleware, and just try to grasp the concept what I'm explaining. Don't get too overwhelmed about the keywords and everything. What it basically does is it tries to execute your request, and if there is any error, what it does is it just handles that error. It intercepts that error, and instead of your framework doing the handling and returning something that's not user friendly, it tries to intercept that error, and it tries to build a generic error message, a very user-friendly error message. And then we also have a lot of variables that specify the settings, what should happen. Should we log errors? Okay, if we want to log errors, go to log errors. Should we include exception detail? Should the detail exception be very detailed, or you should have it a concise manner? Then what we usually do is we basically build out an error detail. So we build out an object, right? So every time any error is thrown, we build the same object. So the response is always same. So if there's just one data contract that you need to adhere to, and then it just does some serialization, convert it into JSON, and return it as an API response. So what I'll do is I'll just go ahead and show you a sample and how it's run. Basically, lets you have a feel of everything. So I just run my application. So it's taking some time to start up and some time to load. So my API is loaded, and so this is a generic path wherein I have some specific errors. So when I send and when I receive an error, okay, okay. So this is the format that is consistent. So whatever the error is, whatever happens, whenever an exception happens, you will always receive the error in the same format. There will be a message, there will be a description if you want to, there will be a details of the exception if you want to, there will be a status code like the error was 500, and if you want to return any additional data. So no matter what exception happens in your entire application, you'll always have the same format. Okay, so for this, there is a middleware. This is basically a component that you can just plug in, right? You can just say, okay, use this. This is ready-made. You just need to install this framework, and you just need to use it. Now, to test it out, what I've done is I've created a real-world API. Okay, so this is a real-world API to actually simulate and how I'm going to use it. So these are some of the sample APIs, like this is not found endpoint, this is the bad request endpoint. So we can actually go on and hit it. So this is like an API call that we made. So in real scenario, you would made an API call, and so you would get some errors. So in the same way, these are some ready-made available that you can test it. So if I want to test it, I want to say no content. So what happens and how we are going to get a response if we have a no content error? So something like that. Okay, so we are getting no content. Okay, and then we also have unauthorized. So we can go and we can say unauthorized. So notice we are going for unauthorized and we are getting the same details and we are getting the same exceptions. So now, so this was just the basic setup. And then we have to test these out, to test this framework out and to test the API out. What we have is we have two different projects. These are test projects. So these are based in MS Test. So as we already discussed, MS Test is a technology that allows us to way to write test cases. And this is the Test Explorer built in the Visual Studio that we can use to execute our test cases. Okay. Just stop sharing. Okay, so this is the format that we will always get an error in. So whatever API call we make unauthorized or something, so we'll always get an error in this format. Okay, so we don't have to change anything. So this is the basic test setup. So if you say, so we have basket.api.framework.tests. So this is one way of naming. So when you have a project, so I have a project basket.api.framework, and then this is a .NET Core application. This is the API application. That's called basket.api. So the test cases for this project, the naming should be consistent. So I have named it basket.api, then dot integration tests, because this is an end-to-end test. So you actually execute the API. It's not just that you are testing it standalone. Then basket.api.framework. So the test case project related to this is basket.api.framework.tests. So when you see this, you know that, okay, this test project is specifically for testing the functionality in this project. So when you make projects, so different projects, so the test case project should be named similar to what we have as a actual project. So if you see, we have different classes in here, right? So different classes have different functionalities. Okay. So and similarly, we have a test case class. So we create a test case class for a collection. So what we are doing is we have created API response test. So we have a class called API response. So what we want is we want to test the functionality inside this class. So whatever is happening, how the error is being formed, how we are generating the errors, we want to test it out. So for that, what we do is we create a test case class inside the test case project. And the naming should be again similar. So API response, so it should be named API response tests. Now inside that, if you see, there's a test class, right? So this is the test class API response test. It has multiple test cases. This is a test case, right? So we have multiple test cases. If you see, so if you see in this view, so we have a lot of test cases, right? Then each test case has a particular name. So here the name has been divided into three different parts. The first part is the method that you're testing. So what we're doing is we are testing not found method. The second part relates to the scenario you are testing. So empty message. So what happens when we send an empty message? Then the third part is what we are expecting as a result. So it should throw an exception. So this is what we are expecting. Okay. Now, if we are testing, this is the second test case. Again, for the same method, not found. So not found we are testing. Then what is the scenario? So the scenario is everything is valid, right? We don't have any errors. So in that case, what should happen? So what should happen is it should return you a response with code and a message. Okay. Now, for each test case, you have a test case body. So like we discussed, there are three parts: arrange, act, and assert. So in arrange step, we just prepare the data and we do the setup. So we are preparing the data. So we are preparing some values and everything. And what we're doing is we are preparing some sample exceptions. Then in act step, we're actually going to call the method. So this is the method that we are testing, not found. So you can see there are a lot of methods: not found, bad request, forbidden. So we are testing the not found method. Okay. So what we are doing is we are preparing some data and then we are calling API response.not found and we are passing in some data. Okay. And based on that, we are getting some error details. So some error detail will be formed. Then the last part is assertion. So whatever we have done and whatever error detail we have received, whether we have received the exact status code. So what we are expecting is we should receive not found status code. Okay. The message should be test. The description should be test description because that's what we are passing in here, right? So whatever we are passing in here, based on that, your implementation should happen, or based on that, you should get a return value. Then the first property should be 1, second property should be value 2. So like here, first property we have passed as 1, second value we have passed a prop value 2. Then error detail should be value 2. Then the message in the exception should be test exception, something like that. So this is how we write a test case. This is basically one basic example of how the test case is there. So we do some setup data, then we call the exact method that we're testing, and then we do some assertion. We basically check. So assert.r equal basically just checks. So whatever response is being returned, whether the data is same as what we are expecting or it's something different. So similarly, we can see that there's an API, so error controller that we saw. So this is just for sample and testing it out, whether the API works with the middleware or not. So we have to test this, right? So we have created an integration test. So it's an integration test because it actually invokes the API and actually tests the API. Then we have error controller tests here, right? So my controller is called as an error controller. So it's error controller class. So the test case for those classes would be an error controller test. So if you come here, you can see that, yeah, here also we have a lot of test cases. So we are testing different methods. Okay, so we have different test cases. So the naming scheme is same, the 3-part naming scheme, the scenario, sorry, the method under test, then the scenario under test, then what we are expecting as a response. Here you can see that we are doing some initialization. So there's some initialization code. So initialization code will run before every test case is executed. So what we are doing is we are creating a API client. So that should happen before every test case should execute. So in the same way, we have the method body, the test case body. So we are setting something, we're calling something. So what we're doing is we're calling the API client and calling a get method on not found. Okay, so that's what we are doing here. And then in assertion, we are checking. So response code should be not found and message should be not found error and something like that. Because from our API, we are doing the same thing. We are returning message and we are returning something like that. Now, this is a basic setup that we have done. And this is our test explorer. So what we can do is we can see that a lot of test cases are there already written. So in total, you can see I have 23 test cases, right? 8 test cases are from framework, basket.api.framework, and then 15 test cases are for basket.api.integration tests. So what we do is we just run them, right? So we'll have to stop the debugging and we can run the test cases. So now your test cases are executing. You can see that everything is grayed out. And you can see that within a matter of seconds, each and every test case got executed. So 18 milliseconds and 1.3 seconds. So that's under 2 seconds. So 23 test cases got executed under 2 seconds, which is around 10 seconds per, 10 test cases per second. So even if you have 1,000 test cases, so I mean, it would hardly take 100 seconds, like 1 or 2 minutes. But just imagine if you have to test those manually, like if a QA has to sit and execute all those test cases manually, it has to go on, run the API, and then make 1,000 test calls to different APIs. So how much time would it take, right? So this is the power of TDD and power of automated testing. Now, I think you must all be set up that, okay, what's the code and what's the projects and how you're running your test cases, and here you have test cases. Now let's take a business scenario. So in a basic business scenario, what we are going to do is we are saying that, okay, I am giving you a user ID, okay, and based on that user ID, you need to return me the details of the user, okay. So thinking about that scenario first, what we want to do is, okay, so if we have a user, so what we want to write an API. Okay, so you want to write an API, so there will be a controller for that. Okay, so what we'll do is we have a values controller. So we'll just go ahead and rename it. So instead of values, let's name it as user controller. Okay. Yeah. So we'll just rename it. Okay. Everything's renamed. Now we have an empty API. So the path to the API slash controller, which means API. Now we don't have anything inside it, right? Now what's our requirement? Let's look at the requirement. So our requirement is somebody is going to pass me an ID, that user ID, and based on that, what we're going to do is we're going to return the details of the user. So for that, what we need is we need an API that should be exposed, which should be capable of accepting an integer argument. So let's go ahead and do that. Let's go ahead and just copy something. Okay. Now modify the roots. So user. Okay. And then we'll pass an ID as integer. Okay. And instead of no content, it should be get async. Okay. And then what we can see 132 an ID. Okay. Let's remove this. Okay, so now we are done. I mean, we are through with the first step. Okay, so we need a user controller. We need to expose an API that should return us a user detail, and it should be capable of accepting an ID of the user. Okay, this is what we would need as a placeholder for writing our test cases. Now, inside this, we are going to do and write our implementation, right? But thinking of the TDD way, we are not going to write the implementation now. Now we need to think about the scenarios that can happen. So we need to think about what we are going to return. So let's just say that we are returning the name of the user. Okay, so we will return the name of the user. Okay, then what we'll do is we'll return the age of the user. Okay, then we'll return the gender of the user. Okay, and then we'll return a description. Okay, so description will basically be like name, comma, age, comma, gender, something like a representation which you can show to the user. So this is our requirement. This is, so now we have gathered our requirements. So this is the first step, that you need to be clear about your requirements, what you need and what your architecture should support and what should be the output. So we need an API which returns these values. Okay, so now for returning these values we need to do some implementation, but before that we need to think about some scenarios. So we need to think about some scenarios and we need to write some test cases. Okay, because we are doing it in TDD way. So let's not write any implementation yet, and let's just say only throw new not implemented exception. So what basically I'm doing is I'm saying that if now at this point, if somebody calls this method, do not do anything. We have not written any implementation, and just say to the user that this is not implemented. So you're not going to get any result. Okay, so now if you have to do a test case first approach, so as we said that for each class we have to have a corresponding test class in place. So for this project, this is the test project, corresponding test project, and for this error controller class we have error controller tests class. So similarly for user controller class, user controller, we will have another class, another test class that will be called user controller controller tests. So we'll just copy this and we'll just rename. So let's name it as user controller tests. Okay, then let's go ahead and delete everything. Okay, so now at the top level what we have is we have our user controller tests. So this is a test class. So this is a way of specifying that this is a test class. Okay, so different, you might use different technologies. You might use Jasmine, you might use XUnit, but the basic premise remains the same. So there will be a class or there will be some logical grouping, and you have to specify that okay, this is the test class. In Jasmine you have to use a describe keyword. So describe keyword specifies that okay, this is the collection of test classes. Okay, and in NUnit is another framework. I think it's test fixture instead of test class, but the overall idea remains the same. So this is the collection of test cases, right? So you can see in the left pane, as soon as I created another test class, you can see that one test case, and it automatically came up at the text explorer window that, okay, you have one more test class and you have one more test method, but the status is that it has not been run yet. So we haven't run anything yet. Okay. Now coming up to the next part. So setting up our test case. So what is our controller root? So the root of the controller is API/user. So it's not error anymore. So we'll just go ahead and we'll change that as the user so that it goes to the correct API. It hits the user API. It does not hit another API. Now this is the portion where we do any test initialization. So this is something that happens before your test case executes. Every time your test case is going to execute, before that, this is going to execute. So what we're doing is we are creating a client. So creating a client is basically what we're doing is we are creating an API client, which means that we are trying to spin up the API, but a dummy version of the API. So we are not actually going to spin up the actual API because that will take a lot of time and a lot of resources. But for the just for the testing purpose, we are going to spin up a dummy API so that we can actually make calls to it and we can actually test it. So this part is also done. We have initialization set up. Now the next part is actually writing the test case, right? So what we're doing is we're actually going to write the test case. And for this, we are writing the test case. And so what we do is we are writing the test case. So this is our test case that we are going to write. So let's just rename the test case first. So what we are going to do is, so our test case should be, so what should be our test case? So think about the test cases and what are the possible scenarios that could happen. Forget about the implementation, forget about everything. Think about what you are going to implement. So you're going to take in an ID. So there might be scenarios wherein you're not getting past the particular ID. So you might receive an incorrect ID or something, right? So your ID must be like greater than 0. So it should be 1 or 2 or 3. So what we'll do is, so the method under test is user controller. So get async. So this is the method that you're testing. So get async. And what is the scenario that you're testing? It returns, so invalid ID, invalid ID. Okay. And then it does not return a response, it throws an exception. So when it throws an exception, we can actually test an exception here, expected exception. So we can expect an exception. And we can say that we are actually expecting an exception. Expected exception type of. So if you have an invalid ID, so what exception should it throw? So it should throw a bad request. Okay, so something like it's a bad request exception, right? So if you see our error controller tests, so we have a different responses for bad exception. So it's actually what we're doing is we are returning the bad request. So okay, so let's leave this alone so we can test exceptions. So let's go into our real deal. So we'll create a test method where we are actually going to test something. So public async task get async. Okay, and valid ID. So if we're passing a valid ID, so it should return user data. Okay, that's what we are expecting. So then we have an arrange. So we'll arrange some data. We'll say some data. So right, if for some data int 32, like ID equal to 10. Okay. So we are having an ID as 10. And then we are going to make a call to our API. So we have already created a client. Okay. So in the error controller test, you can see that client has been created and we can call it using something like this. So we'll say that our response equal to something like this. And what is the path? Path is user and get async. So it will call get, and then we have to pass in the ID. So what we'll do is we'll pass in the ID in here. Okay. And then we will do an assertion. Okay. Now in assertion, what we're expecting that, okay, once we pass in the ID and once we get a response, so assert dot r equal. So we are setting that the name should be test user, something like this, response dot response dot okay. So response dot status code, it should be success. Okay. So we should so instead of testing the response code, what we should do is we should serialize our test case. All right. Serialize our data, and let's just copy something from here so it will be quicker. Okay. So it should be okay. Response should be okay because we are expecting a success. So response dot success code should be success. Then what we're doing is whatever data we are getting back, we are trying to read it. And what we're doing to do is we'll just create here a temporary class, public class user detail. And this is the class which we are returning. So like prop name, then age, and let's take gender as a string. Okay. And another one, description. So what we need to return in the description is just return name, okay, and then comma. After that name, let's return what do you say, age, name, age, and gender. Okay. Now this is what we are expecting to be returned. So we'll just say user detail. Now here is where we'll do the assertions. So what we're expecting is the name should be test user response data dot name. Okay. And similarly, we will expect some more fields. Like we are expecting that age should be 20. Then we are expecting that gender should be F. And we're expecting that based on this, the description that we should come across is test user comma 20 comma F, something like this. So now your test case is ready, our act is set, and our expectations are set. Now what we're expecting this, once we run this, so we should get this response. Let's try to run this test. So here we can run this test or debug this test. If you want to debug and go through line by line, so we can do that. So let's run this test case. So here you can see it's running up. The test case is failing.
Yes, yeah. Just quick one. Yeah, we are almost like 1 hour. So I think
yeah.
Can we just quickly?
Yeah, this is just the end. So
yeah,
we'll just implement this scenario and we'll finish up. Yeah.
Yeah.
Okay.
Yeah, because a lot of people have asked interesting questions, so I think I would like to take some good questions here.
Sure. We'll just finish it up in 2-3 minutes, and then we'll take up the questions straight away. So yeah, this is one scenario. So you can see that what is the result? It's failed. So why is it failed? So we are expecting okay, but we are getting an internal server error. Why? Because we are throwing an exception here. We have not yet implemented anything. So instead of that, what we go in, we'll just implement. So in real world scenario, you will have some implementation like database connection, get that. But for now, what we'll do is we'll just return a dummy data, user detail, and we'll say that, okay, name equal to test user, then we'll say that age equal to 20, and gender equal to if, and description will be automatically calculated. So we are not going to return any description. Okay, so we'll go and we'll run the test case again. Sorry. Okay, let's just spin up a dummy instance and return. Mhm. Okay, I think we have to do some conversion. So we'll run the test case again. Yeah. So now you can see that the test case has succeeded, which means that all of our assertions has passed. So in real world, this will be different, but right now is different. So this is how we implement TDD. But for demonstration purposes, just the last bit I wanted to show you is, so this is a UKit package that we have built on. So the code is in GitHub. And so what we've done is we have, tied it up to pipeline. So this is the DevOps, Azure DevOps the portal that we have. So one basic benefit of having test cases and automated test cases built is, so as soon as you commit something, so this is something I was testing and I committed something around 2 hours ago. So once you commit something, what happens is every time you do, so your test cases are run automatically. So we had 23 test cases and the test cases ran automatically. So here you can see that two test cases failed and the pass percentage was 91.3%, and it took just 19 seconds, the whole thing and everything. And two test cases that failed are listed here. So the build failed and we will not be able to deploy this ahead. But yeah, you can see that the whole process is automated. So right now what I can do is I can just change some simple thing. I don't need to spin up a new instance. Like if I'm going to spin up, I have to run the whole API. I have to run the application, then wait for the application to get loaded. And once the application get loaded, I have to run 23, 26 test cases. And then only I can say that, okay, my build has succeeded or the functionality is successful. And then I can come up here and say that, okay, I can deploy it in production or something. But right now here you can see that all test cases are passing or something is failing or not. And you can easily say that what it is and what it is not. So that's the basic thing and basic benefits. So let's just quickly go to the conclusion. So here we have conclusion just to wrap it up. So TDD actually saves time and effort as opposed to a popular belief. It leads to better management and process, much faster and easier to implement than manual approach. Leads to better architecture and not that difficult to learn that we just saw. Then yeah, of course it has some business benefits. So it actually in long term, it increases the productivity and saves a lot of cost for us, and also improves the expertise of your resources. Okay. So yeah.
So yeah, thank you. Yeah, thanks, Azad. Yeah. So yeah, in interest of time, I will just pick up two
Yeah.
questions. I think considering the time. So yeah, first question, Shehzad, is like as a developer, how to write and execute the test cases. What is the role and responsibility of the QA in TDD? So as the developer is doing writing the test cases. In that case, like what should is the role of the QA in the TDD?
So QA in the TDD, if you see, the role of the QA is to start your test cases early. So a QA is the one who will be actually doing the functional testing at the end, and he will be going the go ahead for the deployment. And he is kind of an SME, subject matter expert for the product. So both the developers as well as the QA need to sit together, and they need to review the test cases, design the test cases. Developers might have some insights which will help the QA. Then QA might have some scenarios which will help the developer. So the developer
Okay.
needs to incorporate all those test cases and then write acceptance test cases. Yes, the QA is important because I mean, we can cover all the test cases and we can cover all the code, but there's still a bit of human interaction which will happen in the real world with the product, which has to
Right.
be tested by the QA.
Okay. 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 Yeah. So one more, like if the project is already developed long time ago, okay, and if they are doing already manual testing, now as a new enhancement they want, they want to do a TDD. So can they do in that case like TDD?
There are several factors. One important thing is how your project is architected.
Mm-hmm.
So you need to know that whether your project is testable or not, because a lot of times, a lot of layers like presentation layer is there, database layer is there, business logic is there. They were very tightly coupled, so you cannot
Correct.
test it out. But yeah, if you have things separated in different classes, so you can easily test it out. So when you're writing new functionalities, try to have them as much separate as possible so that you can test it out.
Right. So
Functionality.
I think, yeah, understood. Like architecture boundaries should be defined, like
Right.
there in the application. Okay.
Right.
So one last question I will ask. So is there any tool available in the market which can help us to record and play test cases?
Yeah, there are a lot of tools available. One famous tool is I can think of is Coded UI, but that's more for automation testing for the UI. Um, I, I I mean, yeah, that will definitely help us in TDD, but that's not actually what we're going to do here. So that's like if you are going to test your UI, like how a user goes on and uses the browser, like he clicks on this button, then what he enters into the field. So for recording and replaying that, we have Coded UI, which actually records everything, and then it makes a test case out of it, and you can execute it afterwards.
Okay. Thanks, Shehzad. Like I know we couldn't address all the questions here today. Yeah, the time is less. And like, however, myself and Shehzad is available on LinkedIn and Twitter.
Right.
I think during the start of the session, we have shared our LinkedIn and Twitter handles. So anytime you can connect us and we'll address your questions and queries. Thank you for being a lovely audience. So see you soon in our next. Yeah, you will get the invite and please respond to that. Until that time, please take care. Maintain social distance. Like mask whenever you are stepping out. Thank you once again. From me, says
thanks everyone for joining in. Thank you for your patience.